So, hi everyone. At this question, first of all, read the question carefully. A uniform circular disk of radius r and mass m is rotating about an axis perpendicular to its plane and passing through its center. So, we have a uniform circular disk having radius r like this. Its radius is r. Next part, what the question is saying: a small circular part of radius r by 2 is removed from the original disk as shown in figure. So, r by 2 means diameter is r, like this. This r, this is also r. Here, so r by 2. This is the portion. This is r by 2. It is r by 2. So it's a easy question like this portion here. If we remove, then we need to find the moment of inertia of this remaining disk. So I am showing the center of disk and this portion we have removed. Okay. So mass is here. If I show, mass is present here. So the portion simply, what is the answer? They are asking for this. Then it is equal to what? We have a complete disk like this. From this, I just subtract moment of inertia of this cut portion. So for this disk, moment of inertia is about the center. Nothing is given like you should assume the axis which is passing through the center, okay, and perpendicular to the plane. This is our axis. So about this axis, moment of inertia is what? For disk, mr square by 2. And we need to subtract the moment of inertia of this cut portion about this axis. Okay. So let's find the mass first of all. For pi r square, mass is m. The cut portion radius is r by 2. So it will be pi r square by 4. So mass will be m by, yeah. So moment of inertia of this cut portion will be this cut portion about the center. This is the this is what we like. Like this. We need to find the moment of inertia of this remaining portion. This is the remaining portion about the center. Clear? Let us suppose it is I dash. This I dash will be I minus I1. I1 is the moment of inertia due to this small disk. So we know that this is mr square by 2 minus I1. I1 is the moment of inertia of this cut portion about this. So what? Just assume here this center of cut portion about this axis. Which theorem I should apply? I will apply parallel axis theorem. About this axis, what I will do? I will apply parallel axis theorem. So moment of inertia of this cut portion about this will be how much? I1. So I1 will be what? Moment of inertia of this cut portion about its center, that is mr square by 4 plus m into square of the distance between the two parallel axes. So how much distance? R square by. Now one bigger mistake I did. What big mistake I did? Just tell me. This mass. It is not m. It is m by 4. M by 4. Yeah. Simply we can solve mr square by 2. How much? Mr square by 2 minus how much common? M by 4. How much? Twice of m by 4 multiply r square by. So you can solve this. Yeah. Tell me fast what is the answer. Mr square common. Want to take common? Okay, I'm solving step by step. I can solve within a minute. But I want you to see the steps. LCM is 8, especially for heat students. Yeah, a lot of problem physics. Okay, so it will be 3 mr square by. Yeah. So this is I dash is the moment of inertia of this remaining part of the this. Did not make any mistake. Check r by 2. We have stability. Oh, okay. Actually, it is mr square by 2 about the center. So m by 4, that is r, that is the radius. Here is 2. Okay, I forget here. So my mistake actually. So like these mistakes we will also encounter here. So make sure while solving, you should be very careful. So m by 4, r square by 4. We can take common. Inside will be how much? 1 by 2 plus 3 by 2. 1 by 2 plus 1. And outside will be m by 4. And what else? R square by 4. Yeah. Now we can take it common. Mr square by 2. We can take common. Is 3 by 2. So it will be 16. Okay. Like this. So mr square by 2. 16 minus 3. 16. 16 minus 3, that is how much? How much? 16 minus 3. 13 mr square by 2. Yeah. So actually I make mistake because solving here is a we are human beings. Okay, we can make mistake, but in exam we should overcome. Yeah. So by solving, I just convey this message. Such mistake you will also encounter. Simple m by 2, simple divide by 2 can make your answer wrong. Okay. So make sure your calculation is very sharp. Yeah. So once again, thank you so much. I hope this doubt is clear. You should focus on calculation. Concept is simple. From bigger disk, moment of inertia of bigger disk is mr square by 2. From that, we will subtract the moment of inertia of cut portion. Then only you will get the inertia of remaining portion. Okay. So thank you so much. Salam.